G'day, it's Clive and Jenny Rock Singer here. I've been chasing this for so long, and the amount of money, I mean seriously, it's cost well over 100 grand to get where I am now. I used to do electronics in my flat and the guy tried to kick me out. He said, oh no, he said you'll catch fire to the place and burn the place down. My insurance won't cover it. They don't like you doing electronics. You do electronics at home, you get it all set up, your mum comes home and says, oh wonderful, you're doing electronics, yeah, clean it all up, we're going to make tea. No matter how hard you try and do electronics at home, you're going to find roadblocks all the way down the way. So what I found is I did tests with AC coming directly off the mains, running through this thing I made up, and I cut it down through this thing here, in conjunction with this, which is I think around about a 50 watt resistor that I got off the internet. I think it cost me 20 or 30 bucks or 60 bucks or something. I bought an inductance capacitance meter. I got myself a brand new Coil. I've had to now own my own house outright. I built this thing to handle high wattages. I've got coils that I made up myself, and I got 0.03 and 0.04 micro henries or millihenries off those, and I also bought some other ones that are actually all different values. They're 3 different values. They're coils for testing this. I put a capacitor directly off the mains and I couldn't do anything, and I couldn't get any effect from a coil either. So my theory is that you don't go through a power supply, you need an AC input. And if you do electronics, the first thing they do is sit you in front of a power supply. If you're going to design a power supply, you've got to come straight from the mains. But you don't wire it directly into 240 volt, you go through a step-down transformer, which is what that is. I'm allowed to work, I did BEC, and I'm allowed to work on this side of the transformer. I'm not allowed to work on the other side. I wired that up, but I took it on A-grade electrician. My mate used to be a B-grade, and he said all you got to do is take it to an A-grade electrician and he checks it and then you can turn it on. I can wire it up, but I'm not allowed to turn it on. But I'm allowed to wire it from this side. This is your 12 volt side. So there's only 12 volt AC coming out of this, and so I put that directly into this circuit here, that resistor there. I put coils into the circuit, and I want to see if it changes the frequency. Now I couldn't get any change in frequency at all, and I have a theory about this, that the frequency they're talking about is, they talk about carrier waves in radio. When a signal travels through the air, it carries on a carrier wave. I believe these AC sine waves going through the circuit don't change, but the signal, when you put a buzzing through the circuit, and I think you have to have a transistor. I think you've got to have a 3-port circuit. You've got to have a positive and negative input, and I don't think you can put a signal through an AC circuit like this, because it doesn't have a third input. And you're confusing the AC power sine wave with the signal. So there's no way to put a signal in it, and I think the transistor is the only way you can put a signal into a circuit. So I've got a single stage, so I've got a 2-stage amplifier there that I've made up, and what I'm going to do is I'm going to feed the 240 in. It's going to come out 12 volt or 6 volt or whatever I put it on there. These are different values along here. I'm going to put it to, I think I put it down to 6 volt. Get it right down to a few milliamp and a few microamp. Feed it into a circuit and see if it changes the frequency, running it through these coils, which I now have. I've got homemade coils I've made up. The trick is you burn the ends of them. I was out there scraping them with a Stanley knife, and it turns out all you got to do is burn the end of them and you get contact. And I got readings off both of those. And there's a little, as a matter of fact, what I'll do is if I put it on there, I'm going to do this one-handed, that one there, and where's the other one? The other one is, I think there's the other one there. It's putting power through this circuit. That's how it gets the reading, and that should come up as 0.04 millihenries. Minus 0.03 millihenries. I don't know why it's minus. I don't know what the story is there, unless it's less than less than that, unless it's micro Henrys, which is quite possible. But anyway, I'm getting a reading off that. There's definitely a reading coming off that, and I'm getting readings off my other ones. So now I've got the whole lot set up. Own my own house, can't get kicked out. I do the complete. I've got a circuit there that I've got worked out. I've both got it worked out in peak to peak and also in voltage RMS. My new Crow's got voltage RMS and average and all that on it, as well as the sine wave. And I'm going to do a complete test with the circuit with a coil in it, and I'm going to see if I can change the frequency. So it turns out that the coil changes the frequency, and the capacitance changes the level of the frequency. So you've got, I think you go 5,000 hertz, but when you want to chop off a particular frequency range, you use capacitor, and it actually clips the top off the waveform, so it reduces it, passes it off to earth. And so you can actually you can reduce the frequency coming out of the speaker. I reckon that's signal. I reckon the AC sine wave doesn't change, but when you feed a buzzing effect through an amplifier, the signal that comes out the other end is a change in frequency, but it's audible, which can be checked with a dB meter. I've got a dB meter there. I've got all this new equipment. Where's my dB meter? I've got a dB meter here. I've also got a thing for checking RPM. Oh, that's a tester I bought for testing my leads. I've got an RPM meter there somewhere. I bought a heap of new equipment. Oh, there it is there. That's my RPM meter. So yeah, now I can check all this stuff now, and it's what I've wanted to do for years. But the thing is, you don't go through a power supply, it's DC. You need an AC wave from a dirty waveform coming straight through the mains, step it down until you run it through the circuit, and then run it through a coil, and find out once and for all what's the wave going through this coil. And I've got 3 different values of coils there, and I'm going to test them all and do theoretical calculations. And if it doesn't change the frequency, then it's going to confirm what I believe, is that it runs on the carrier frequency, and it doesn't change it electrically, it changes it through signal. So the signal's got to go on top of the carrier wave. But that's a theory at this stage. And now that I've got a frequency, and I've also got a function generator right down the back as well, and I can feed a high frequency sine wave through it. So yeah, now I've got to set this all up, and I can do some calculations. So Clive Rocksinger over and out.